Zero product property. All right, what does that word product mean? In math, times, good. So if I'm timesing and I want my answer to be 0, let's think about our options. What times what is 0? 0 times 0, Celine. Hi. 0 times 0 is 0. That's one option. Is that the only thing we could ever multiply in the whole world to make 0? What else could I multiply? 0 times any number. 0 times 1 is 0. 0 times negative 6,782. 0. So I'm going to say 0 times x equals 0. And then there's one other way we can get 0 as our answer. What's my last way? What? Yeah, something times 0. So I'm going to do y times 0. If 0 is in that second position, the answer is still 0. So I'm going to use my highlighters for this 0 product property today. If you'd like to use those, you can go ahead and color code. All right, so we're going to write this in words. It's kind of like our only writing in words that we're doing today. If 2 parts multiply to 0, if 2 parts multiply to 0, you need a pencil? Okay. Get going, bud. You can do this. At least one part equals 0. So at least means it could just be one of the parts, or it could be both the parts. All right, so we're gonna try this out with our first example. Got a couple people still writing, so I'm gonna pause for a moment. Caesar, come on. Effort. You can do this. Really? Really? How's that?
Time's up.
We'll finish after, because then the next round is going to start, and then it'll be like 2 more minutes, and then 2 more minutes. All right, so number 1, we're going to solve. That's our goal. When we solve an equation, our answer should look like what? Look back at yesterday, or not yesterday, but Thursday. H3, what does solving mean? Go ahead, find the answer, and what should our answer look like? Yeah, like x equals or j equals whatever our variable is. So we're going to solve this first one is 8v minus 1 in parentheses. Is that a monomial, binomial, or trinomial? Good, binomial. And we're going to multiply it by another binomial. So again in parentheses, v plus 3 equals 0. So this isn't quite a flashback yet to last chapter, to Unit G. This is still just kind of our new idea of the 0 product property. So is this a product? Do I have a multiplying problem? Hi. Okay, away. Away. Good. Is this a multiplying problem?
Yes.
It is, right? Where is the times? Good, in the middle of the parentheses. There's also a times where. That 8 and b, and then, yeah, just that, 8 and b. But when I talk about two parts, we're talking about that multiplying that's right in the middle. So I'm going to put that multiplying sign in the middle if we need it. And if I have two parts that multiply to 0, what does that tell me? Either the first part is 0 or the second part is 0. Good. I think I'm going insane. Oh, there it is. Never mind. I'm not going insane. All right, so we're going to break this up into two equations. Either that first part, 8v minus 1, is going to equal 0. Or, what's the second case? V plus 3 would equal 0. And then this just brings us way back to trimester 1, back to unit A. We're just solving those equations just like how we have been. And we're just going to solve each of those equations. So I'm going to draw a line down that equal sign. My goal is to get V by itself. So in that first part, 8v minus 1 equals 0. Do we undo the 8 first or the 1? The 1. And if I see a minus 1, how would I undo a minus 1? Add 1. Good. And if we do it to one side, do it to the other. You guys are like, Miss Morrell, we know this. Yep. Add 1 to both sides. So 8v equals 1. Not done yet. Our goal is to get v all by itself. So our next step is, good, divide by 8. All right, if I do 1 divided by 8 in my calculator, oh, sorry, on the left side we get v. And then on the right side, we have to do 1 divided by 8. We get a handy-dandy decimal. Okay. We want someone in the math universe said for these types of problems, we want our answers to be fractions. So we're going to leave it as 1 over 8. I don't know who exactly decided that. Someone somewhere was like, nope, we like fractions. We don't want rounding. And it's probably because these problems build up to even bigger problems, and if we round now, then our bigger problems will be wrong. So that's one answer. V is 1/8. This first part will be 0. Doesn't matter what the second part is. 0 times that will equal 0. But we have another solution. The second part could equal 0.
God.
Yeah, for real, right?
You like this.
I don't. All right, v plus 3 equals 0. If I solve that, what am I going to do? Minus 3 to both sides. And v would equal negative 3. And that makes that second part 0. So then whatever the first number is times 0 equals 0. So our final answer, if you want to write it nice, if you want to just circle, you could to have your two answers. If you want to write it nice and professional, we would write v equals 1/8 or v equals negative 3. Remember with quadratics, we have options. It could have two solutions.
Why would that be 3? I thought it would equal 0.
Because it's minus 3. So if I start at 0 and go backwards 3, we end up at negative 3. Did you have a question, Ifra? Say it again. Yep. So it's one or the other. Either v equals 1/8, that's going to be 1 time. That's one answer. If I put that in, this first part would be 0. 0 times.
miss, I need the answer.
It doesn't. 8 times 1/8.
Oh, the V becomes.
Yeah, the V is 0. All right, so then we get 2 answers. When we have quadratics, there's options that we could have 2 solutions. What's another option? 1 solution or no solutions. Remember, it doesn't even touch that parabola. Does that make more sense, Ifra? No?
Yeah.
Okay. All right, we're going to do one more problem. This one I know, this one you're going to be like, oh my God, this one takes forever. I'm telling you, yep. Tomorrow we're going to do one problem and it's going to take up the whole page. Today we're doing 2 problems that take up the whole page. I know. It's impressive. You guys got to be proud of yourself that you know that much math, that you know a problem that takes up a whole page. First grade you would be just insane. All right, here we go. Number 2. We're going to solve. Ooh, bless you. 3x squared. All right, Anthony. Minus 10x. Can you pick a height and leave it? Minus 25 equals 0. All right, so this is going to combine what we just learned with what we did last chapter. What we just learned is if I can break this up into 2 parts, then I solve each part for 0 and find my 2 answers. Is this currently written like 2 parts that I'm multiplying? No, but that was the whole point of last chapter, was to take this part, 3x squared minus 10x minus 25, and write it into 2 parts. So we're going to do everything we learned last chapter and then some. The last part, the and then some, isn't as bad as it sounds, I know. All right, so first step, we're going to identify what is our A, our B, and our C.
3.
3 is the,
Squared, 3x squared.
yep, is A. What's our B?
Because it comes first.
And it goes
So
with the x
10x.
squared. Is the B, because it goes with the x. And C?
20, 25.
Good, we're going to think of it negative 25. All right, I'm going to color code this. If you'd like to also color code, you can. I'm going to use 3 colored pencils for this one. I just organized those bins, so they should be in those parts. All right, because this one is a longer process, when you get to these types of problems on your practice or on a test or in Algebra 2 in 2 years, you're going to look at this and you might be like, oh my God, this is so much work, I feel so overwhelmed. But when we take time, when we break it apart into each part, you know how to do each part. So you're going to be taking it part by part. So we're going to start with a multiplying problem. What parts do we multiply first? Good. A times C. So what is our A? 3 times what is our C? Negative 25. Anyone got that for us? 3 times 25, that's like quarters. 3 quarters would be 75. Why negative? Positive times a negative is a negative. All right, we always wanted to add up to what, though? Our B, good. And our B is negative 10. Most people, if they get stuck, this is the step they get stuck on. They're like, I don't know, there's lots of numbers that add up to negative 10. You're right, there are lots of numbers that add up to negative 10. This is the part where we grab that factor sheet, that yellow sheet. I'm not going to look at 10 on my factor sheet. I'm going to look at my multiplying problem. My multiplying problem was 75, so I'm looking at 75. If you find it, don't say it quite yet, because I'm going to think through that again for a couple of us that are still writing down. All right, at this point, to find these two numbers, we look at our multiplying problem as 75. So I look at my multiplying sheet, my factor sheet at 75. I need to think which one of those could either add, or I can think subtract to 10. Does 1 plus 75 make 10? 3 plus 25? No, that'd be 28. What about 5 plus 15? No, that'd be 20. So none of them work with adding. Now we're going to think subtracting. 75 minus 1. 25 minus 3. 15 minus 5. Yeah, that'd be 10. Do I want 15 minus 5 or 5 minus 15 to make a negative? Good. 5 minus 15. Most people, when they get stuck on this type of problem, it's there. They forget where they're supposed to look. Look at that 75. Figure out what makes that negative 10. Next step. We can go to that area model. On your test and on your practice, this model has been filled out for you a little bit. So today is a good practice for us to fill it all out together. What goes in that first box?
75?
That A. Then the very first, this one here. This one should be our first, our A, 3x squared. The part that doesn't matter is coming up soon, though. In the very last box, our last part, we want negative 25. Now for this part, it doesn't matter which one goes where. This has to be our negative 10. But instead of saying negative 10, we split that up into two numbers. What two numbers did we split it up into? 5 and negative 15. So it doesn't matter which one you put where. I'm going to put 5 on top here. And they get x's because that 10 originally was a 10x. If you flip-flop these, we're going to get the same final answer, but what you write on top and to the side will be flip-flopped also. Okay? All right, then we start factoring. So we're going to take that yellow sheet. We're going to look at, do we want to look at 3 and 15, 5 and 25, 3 and 5, or 15 and 25?
15 and 25.
Okay, 15 and 25, so we're looking at that bottom. I look at 15 and 25. They both have a 1. Is there anything else that they both have? 5. Anything else?
10.
Neither of them have a 10, you crazy person. So just 5. So across this bottom, we did 15 and 25. So I'm going to go in front of the 15 and 25, and I'm going to write a 5. I'm going to notice if there's anything else that they have in common. A negative. Good. Do they both have an x? Nope. So you might have picked that one because in your brain, you might have known 15 and 25. Biggest number is 5. You didn't even have to look at your sheet. All right, we could continue to do that process, or we can think multiply. I noticed a lot of you on your test.
Wait, where do we get negative 5?
We looked at 15 and 25 and said what was the biggest number they both had. And they both had a 5, and then we noticed they were both negative, so we made it a negative 5. So a lot of people on their tests continue just to factor, and that's fine. So if I look at 3 and 5, what's the biggest number 3 and 5 both have? Well, this one has 3, this one doesn't. Just 1. So I'm going to put a 1 in front of that 3 and 5. Is there anything else that they have in common? They both have an x. So 1x, because they both have x's going across.
Wouldn't it be x?
Do they both have x too?
So 3 then, right?
3 has x2, but the 5 doesn't, so they just both have 1x together. So just take out 1x. All right, now if I look at 3 and 15, what's my biggest common factor for 3 and 15? 3. And we can double check, does that multiply? 1 times 3 is 3. 3 times negative 5, negative 15. What else do they both have? X. When we factor out, usually we're just going to factor out one x in each spot there. Because now x and x together make that x squared. All right, what about 5 and 25?
10. 5.
5. 5 or negative 5?
Negative.
Are they both negative?
No,
Nope.
one of them is. But 25 is bigger.
You're right. You're right. That's if we were going to add or subtract, but with factoring we don't do that, so just 5. It's okay, there's lots of little rules. All right, so now let's write our answers with our binomials. What do we want our first binomial to be? 3x and 5 go together. And then? Good, 1x minus 5. Are you guys okay if instead of writing 1x, can we just write x?
No.
You want the one there?
Yep.
Okay. 1x minus 5 equals, overall, what did our whole equation equal at the beginning? 0. So far we did what we did last chapter. We've done what we accomplished last chapter. We factored it. Now we have to solve it for 0. This is the part that's new today. Again, it feels like there's another step. Really, this feels like the most work. The second part to me feels less work because it's stuff we've already done. Yeah. That's all we did last chapter. Now we're going to say either this first part could equal 0 or the second part equals 0. So if you need to write really small here to fit this in on the same page, write really, really, really small, or right next to it. So 3x plus 5 equals 0. That's our first part. Or 1x minus 5 equals 0. And then we solve each of those. Now for your quick check today, because this one's a drag and drop and there just would be too many dragging and too much dropping, it's going to go from this to the answer. The in-between parts, the steps you take to solve, you'll have to do either on a whiteboard or a scratch paper or in your head. Okay? But this middle part won't be on the quick check. The last part on the quick check will just be the answers. It skips over this part because it was too much. So then we just solve each of these equations because remember our overall idea was to solve. So in this first one, do we get rid of the 3 first or the 5? 5. Good. We're going to minus 5. Abdi Malik. Phone away. Subtract 5 from both sides. If I do 0 minus 5, what do we get? Negative 5. Yeah. And then to get x by itself, we need to undo that 3. So how do we undo a multiplying by 3? Divide by 3. Can I do negative 5 divided by 3? Nope, so I'm just going to leave it as negative 5 over 3. So that's one answer. I know, so much work. You guys are doing so
Do
good.
we get 2 answers or we got to combine those 2?
Just 2 answers, then we're done. It's the last step, I promise. I'm going to show you one more thing, but we're not going to write it. All right, last step here is now we're going to solve for this x. So what am I going to do to both sides on this one? Add 5. 1x is really just the same thing as x. So x equals, the 5's cancel out because it was a minus 5 and a plus 5. So we're doing 0 plus 5. 5. All right, if you wanted to, you could just circle these two answers and say those are my answers. If you want to write it nice, you can write x equals negative 5/3 or x equals 5. Now, I'm going to do something here. You don't have to do this part with me, but I want everyone to watch and pay attention to this part because sometimes when you do these long math problems, a lot of times when we do these long math problems, it feels like we're doing math to do math, and then we get this answer, and we're like, I don't know what that answer means. It's just an answer. Okay, our goal was to go back to our original problem. I'm going to cover this up for a second. We had 3x squared. So if I type that in my calculator, I'm going to do 3. But instead of x, what do we use? Use those parentheses, right? Squared minus 10 parentheses, minus 25. All right, what were the two numbers that we found that we want to put in for those parentheses? Negative 5/3. And if I put that in both, what is my answer? What did we want our answer to equal? 0. Did it work? Yep, equals 0. But that's not the only answer. What else could I put in to make my answer 0? 5. And my answer is 0, so it works. All right, that was a lot. I agree.